My name is Flash Isaac, and I'm a teacher from the future. When I was much younger, I saw thousands and thousands of people fail Jamb and unable to gain admission. This made me travel in time. Now I am back with the Flashlearners Jamb app and a series on YouTube tagged 120 Days to Jamb. My mission is to help you blast Jamb and as well get justice for everyone who Jamb has served breakfast. You are still watching 120 Days to Jamb Physics with Flash Isaac. Now, today we shall be taking a look at elementary modern physics. Modern physics is a branch or part of physics that was developed around the 20th century, and we are in the modern era. Modern physics focuses on atomic physics or atomic theories. It focuses on nuclear part of physics or nuclear physics. It focuses on quantum physics. It focuses on relative physics, which is the relative theory of relativity by Albert Einstein. It focuses on quantum numbers, the theory of atoms. All these are the focus of modern physics. And there are a lot of topics, a lot of interesting stuffs you will encounter under modern physics. What Jamb expects you to know when it comes to modern physics are the atomic structure. What is an atom and what is the structure of this atom? Remember, physics is the study of matter in relation to energy. And matter is anything that has mass and occupies space. The unit of matter is atom. Matter are made up of atoms. So, you cannot study matter without studying atoms. So, what should you know about atom, the structure, and what are the theories of atoms? Because a lot of persons proposed atomic theory. For example, John Dalton made an early attempt where he said that atom is the smallest indivisible part of a substance or of an element that can take part in chemical reaction. He said that atoms can neither be created nor destroyed. He did very well as someone who started the theory. He was also able to explain or support the law of conservation of mass, the law of constant composition, and the law of multiple proportion. Then we need to know energy quantization, because energy is in form of packets, which is referred to as quanta. We have packets of energy in form of quanta, and energy is hf, which is Planck constant times frequency. Then we need to know energy levels so long modern physics is concerned and so long Jamb is concerned. Then we need to know black body radiation. We need to know atomic spectral radiation. We need to know thermonic emission. We need to understand photoelectric emission. We need to understand nucleus and radioactivity, because atoms are made up of nucleus, and this nucleus can be unstable. When they are unstable, they disintegrate, explode, giving us various radiations. And the major radiations are alpha radiations, beta radiation, and gamma rays. So, nuclear physics or nucleus and radioactivity is something we focus on in modern physics. Then you should know wave particle paradox. This is something you should know. Then you should know wave mechanics model. This is a theory proposed by major big boys like Louis de Broglie, Erwin Schrödinger, and Werner Heisenberg. All these guys, they gave the modern theories of atoms, thereby introducing the concept of orbitals. Electrons are moving so fast that they don't really behave as particles, or they behave as waves. Now, since they behave as waves, we cannot decide the particular position of electrons at every point in time, but we just give probability that, okay, this electron with this particular energy level should be here. So that is the concept of orbital and quantum numbers, giving us various quantum numbers like principal quantum numbers, azimuthal quantum number, spin quantum numbers, and magnetic quantum numbers. Then to arrange electrons, we use principles like the Abba's principle, Pauli's exclusion principle, Hund's rule, and Heisenberg's uncertainty principle. All this sounds interesting, and some parts may sound strange. I am comfortably using all this grammar for you because I have covered most of the things I have mentioned, and there is a high chance that you've seen all those videos. But if you've not seen these videos, this is it. When it comes to elementary modern physics, I will not talk about atomic structure. Reason already covered in episode 16 of the 120 Days to Jamb Chemistry. So go to the Jamb Chemistry playlist, episode 16. You will see everything under atomic structure. And if you've been following this series simultaneously, I am sure you've watched this video. I will not talk about atomic theories because that is atomic theory, Rutherford's atomic theory, J.J. Thomson's atomic theory. In fact, even the modern atomic theory, wave mechanism model, are explained in episode 18 of the 120 Days to Jamb Chemistry with Flash Isaac. No need repeating that. I will not touch energy levels because energy levels and quantum numbers, even electronic configuration, are already covered in details in episode 20 of the 120 Days to Jamb Chemistry. 3 with Flash Isaac. I shall not look at nucleus and radioactivity because I released 3 long videos in episodes 20, 23, and 26 of the 120 Days to Jamb Chemistry with Flash Isaac. Now, these are the things I want to really talk about. To end this episode, I will quickly touch black body radiation and atomic spectra. Then, in the next episode, we'll talk about thermionic emission. Probably next to, we'll talk about photoelectric emission. Then, we'll look at wave particles paradox. Ladies and gentlemen, I shall also not talk about wave mechanics in details because they are also treated in episode 23 and episode 18 under wave mechanism model and electronic configuration. So this is partially covered. Now, black body radiation. Black body radiation is simply thermal radiation from a black body at a given temperature. It is the thermal energy or heat emitted or radiated from a black body at any given temperature. Now, what is a black body? Black body can be explained under these 4 headings. 1, it is a body which absorbs all the radiations falling upon it. I don't know whether you notice something. On a hot day, if I am putting on white or another color and you are putting on black, pure black, you will feel heat more than I do. Why? My white or maybe another color can reflect heat. It does not absorb all the heat falling upon it. But black absorbs more heat than white body. And if you look at our roofs, they are usually shiny or probably white or a color that appears shiny. This is to make sure that the heat upon it is being reflected If all these roofs or all these bodies absorb all the heat falling upon them, the temperature will be so high that you feel so much heat and uncomfortable even in your own house. But for black bodies, they absorb almost every heat falling upon it. Now, a black body is a body which emits radiation in irregular intervals. It does not emit radiation all the time. It's just irregular intervals it can emit. But when it comes to absorbing, that is what it is good at. And a black body is a body with no reflective power. Most black bodies, they don't reflect. No, their own is to absorb. This is why absorptivity and emissivity of black bodies is one. They perfectly absorb. So, thermal radiation or radiation of heat from a black body is referred to as black body radiation. How about atomic spectral radiation? Atomic spectral radiation are radiations produced when atoms or molecules of matter are excited. Under wave mechanism model, I said that when electrons gain energy, they are excited, they move to a higher energy level. Now, when electrons lose energy, they'll go back to lower energy level or to ground state, which means the level an atom is depends on the energy it has lost or the energy it has gained. When an atom gains energy, we say that it is in excited state. It is excited. As such, the radiations produced when atoms or molecules, which is electrons generally, of matter are excited. These radiation they are produced at the excited state, that is referred to as atomic spectral radiation. Ladies and gentlemen, that is it for elementary modern physics. Next episode, we shall be looking at thermionic emission. I trust you found this video interesting. Feel free to let me know how you feel. Feel free to subscribe to this channel and feel free to tell your friends about the Flashlearners YouTube channel. If you have questions, let me know. And get the Flashlearners Jamb app and begin to answer questions under these topics. The app is offline and it is more than enough to make you pass. See you in the next episode.